process of putting this rational function into a function transformation form, so this form here, requires doing long division. So if I have this function, 3x plus 3 divided by x minus 4, I can divide the x minus 4 into x plus 3. And by dividing, I would do this. I find the number of times that x minus 4 goes into x plus 3. That would be once. So 1 times x minus 4 gives me the x minus 4 here. And I subtract these two terms. I end up with positive 7. So plus 3 minus negative 4 gives me 7. That 7 is my remainder because this expression cannot fit into that 7. So then once I get the quotient in blue and the remainder in green, I can rewrite this expression using this definition. The sum product of some polynomial divided by a divisor gives me the quotient plus remainder over divisor. So I rearrange it like this. There's my remainder divided by my divisor plus my quotient. That puts it into the same form as this expansion with a shift, horizontal shift and vertical shift. So there's my vertical expansion, there's my horizontal shift, there's my vertical shift. Okay, so then when I draw this, I'll end up with the exact same graph, but it's going to be from a slightly different perspective. I have my vertical asymptote at positive 4, so that's the same thing because my divisor is the same. My horizontal asymptote, instead of using a limit to get my horizontal asymptote, I can just use my vertical shift of plus 1. And then using my table of values, so my two reference points that I'm using were negative 1, negative 1, positive 1, positive 1, and my transformed coordinates, I'm going to times by 7. And, sorry, I'll do my x's first, so I'm going to go right 4, so it's going to be 3 and 5. And then the y coordinates are going to be times by 7 plus 1. So times by 7 plus 1 is negative 6. Times by 7 plus 1 is positive 8. So when I draw in these reference points, I go 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. So there's my point. I know that this graph is going to follow this asymptote through this expansion point and through here. Notice that my 0 and my y-intercept, I did not adhere to the same 0 y-intercept because that information is not given here. And then I go 5, 3, 4, 5, 6, 7, 8. So that shows me my vertical expansion again, and so I draw in this place here. So there is some detail left out here in that before I had the y-intercept here and a x-intercept of 3. So if you want to include those, you could, and you can get a much more detailed graph by doing that. Okay, but really the only two coordinates that we're really keeping track of are going to be these two expansion coordinates.